All right, it's time for section 2.3, properties of functions. I'm psyched about it. Riverdog Jenny is apparently not as psyched about it. That's all right. You know, we had quite the day here. We were working on the boat today. My steering cable frayed and snapped last night when we were coming home. So we got home, which is cool, but didn't really have a whole lot of steering, so to kind of move the motor best we could, and eventually we got home. So just another day in the life of riverboating. Wonderful. Exciting. Okay, let's hop to it. Not as exciting as this, though, I'll tell you what. So a function is even if, for every number x in its domain, the number negative x is also in the domain. Okay? So f of negative x would also equal f of x. Cool. In other words, in an even function, for every point x, y on the graph, the point negative x, comma, y is also on the graph. All right, we'll go through some graphical examples as well here in just a sec so you can get a visual representation of this as well. We're doing some of the algebraic approach in a couple later examples. All right, a function is even if and only if its graph is symmetrical or symmetric. I ran out of room there. That looks terrible. With respect to the y-axis. Okay. A function is odd if for every number x in its domain, the number negative x is also in the domain. So f of negative x is equal to negative f of x. Lovely. In other words, in an odd function, for every point x, y on the graph, the point negative x, negative y is also on the graph. So a function is odd if and only if its graph is symmetric with respect to the origin. Woo! Very cool. Wonderful. All right. So here we go. Graphs. Wonderful. First one, that is a quadratic function, negative quadratic function, if you remember. And is that symmetric about the origin or about the y-axis? It most certainly is symmetric about the y-axis here. So this one is an even function. Next one. Is it symmetric over the y-axis? No. If you were to fold it over, would not match up. Is it symmetric about the origin? Well, we can't. Here's my origin, right? It's sitting up higher. Nope, this one is not going to be symmetric about the origin, but this one, so this is neither. And then this one here, well, this is the origin, right? If I were to take this point right here and I were to essentially rotate it, right, and go this away, this point would match up with this one as being, here we have x comma y. This would be my negative x comma negative y. Oh, so origin. Cool. Moving on. So let's do some algebra. All right, the algebraic approach here. So we're going to use the definitions of even and odd functions to determine whether or not it's even, odd, or neither. Okay. So let's see here. We have f of x equals x squared minus 5. So first I want to test to see if it's even. Okay. Meaning, does f of x equal f of negative x? Well, let's see here. What is f of negative x? Well, if I toss in or substitute in a negative x in for x, do I get the same result of what I started with? Well, if I square a negative, it becomes positive, so I get x squared minus 5. And that's the same as f of x. So yes, f of x, which equals x squared minus 5, is equal to f of negative x. Even. Woo woo! If we were to graph this, we would see a parabola, right? A quadratic function going through the y-intercept of negative 5, and it'd be symmetric over that y-axis. Cool. Now, we have g of x equals x cubed minus 1. Let's see here. Well, if I first test to see if it's even, g of x being equal to g of negative x, let's see here. So g of negative x well, that's going to be negative x cubed. And if we remember, that cube is not going to change the sign there, so I'm going to be left with negative x cubed minus 1. Well, so g of negative x does not equal g of x. So not even. But we can still test to see if it's odd. So let's do that. So I want to see now is, and I'll switch colors for the second test here. I want to see, does g of negative x, does that equal negative g of x? That's our question. Okay, well, let's see what's negative g of x. I pop a negative out in front, and there's really two ways of looking at this. I can distribute this negative, giving me negative x cubed plus 1, which we know is not equal to what we got for g of negative x. So we know that this is neither. The other way is you could always take your g of negative x and you could factor out a negative to get a negative out in front, and you would see this. And you would know right away that this right here is not the same as that. Okay, so you could see it either way there. I've seen people do it both ways. Okay, cool, awesome, wonderful, fantastic. Let's keep moving. I'm going to go with green. So let's see here. First, we'll test to see if it's even, meaning does h of x equal h of negative x? Okay, so if I do h of negative x, and I pop in a negative x here, I substitute that in, and then I substitute in a negative here. What do I get? Well, we know that the negative's going to stay the same when it's cubed, right? It doesn't change the sign. I get negative 5x cubed, and then I would get plus x. So that is clearly not equal to h of x, right? So that's not equal to h of x. So it is not even. Not even. But is it odd? Let's test. So I want to see now, does h of negative x equal negative h of x? And again, there are two ways of doing this. How about I do it the other way that I talked about after on the last one? Well, if I take, I can make h of negative x equal, and I'm going to take out the negative, leave me with 5x cubed minus x. Now, does that equal h of negative x? Let's find out. Well, negative h of x. Well, that one right there, if I took my original function, I pop a negative in front. That certainly looks the same, doesn't it? Odd. Cool. All right, so I could have distributed it, or I could factor it out. You know, it's really the same amount of steps, just how you would like to think about it. Okay. Jenny, we following along here? You still good? Looks like you changed positions a little bit. All right. Cool. Let's keep going. So now I have an absolute value function. So let's test for even. That is a capital F. I'll keep it as such. And then we want to see, does that equal f of negative x? Okay, well, f of negative x equals that. Well, what does an absolute value do? It makes everything positive. So it's going to become the absolute value of x again, so if we have this equals that, we know that equals f of x. So even. Woo! Yay! I'm super psyched about that. That was fun. All righty. Cool. So remember those substitutions there. Be careful with your negatives. However you want to address the testing for odd when you're either factoring out the negative like we did on this one, or if you're just distributing it in like we did here originally and then talked about the other option. Just make sure you're really careful with those things, okay? All right, now we're going to talk a little bit of increasing and decreasing. You've seen this in Algebra 2. We're going to get a little more formal with it. As far as some of the wording that we use, you'll see a lot more of a robust vocabulary in pre-calc honors compared to previous classes as we ready you for the wonderful calculus class. Alrighty, the function f is increasing on an interval I if, for any choice of x sub 1 and x sub 2 in I, with x sub 1 being less than x sub 2, we have f of x sub 1 is going to be less than f of x sub 2. Meaning, as you move further and further, I got to do this backwards now, further and further to the right, as your x values are increasing, your y values, your function values, are also increasing. Now, let's talk decreasing. So a function is f is decreasing on an interval I if, for any choice of x sub 1 and x sub 2, same kind of scenario, in I, with x sub 1 being less than x sub 2, so we're moving from left to right on the graph, we have our function values, f of x sub 1 is going to be greater than f of x sub 2. So as we go from left to right, from smaller values to larger values, now our function values are getting smaller. So as you move to the right, the value is less. So it is decreasing. A function f is constant on the interval I if, for all choices x in I, the values of f of x are staying the same, right? Are equal. Cool. So in other words, if a function is increasing, then as the values of x get bigger, the values of the function also get bigger. It's often helpful to put our very, mathematically technical vocabulary talk into normal words, so we make sense of what we're saying with the proper math notation, what it means in real words. So it's helpful to have those too. Alrighty, using the same idea, what happens when a function is decreasing? As let's see here, we can use the same vocabulary. As the x values get bigger, the values of the function get smaller. Awesome. Alrighty. What happens when a function is constant? Any thoughts? Any thoughts? When the function is constant, they stay equal, right? Function values stay equal. They're fixed values, right? They're not changing at all. All right. Awesome. So now I want to use the graph to determine where a function is increasing, decreasing, or constant. Determine where the function is increasing, decreasing, or constant from the graph. All right, cool. So pretty much the same. So where is the function increasing? For increasing, how about I'll do green, and for decreasing, I'll do red. And yeah, we'll see. So let's start with increasing. So as I move from left to right, the function values are increasing. So it looks like this part right here is increasing. So I'll put some arrows like, hey, yeah, we're going up. Okay. Anywhere else, doesn't look like it. So from the x value of -4, not including it, up to the x value of 0, it is increasing. Now, the reason why we don't include the values is because at any specific point, it's not doing anything. We can only speak to what it's doing over an open interval. Okay. So from here to here, it is increasing. But at -4, it's doing nothing. At 2, it's doing nothing, right? We can only speak to increasing and decreasing and constant from over a particular interval, okay? So where's the function decreasing? I'll do that in red, as I said. Okay. Well, looks like this stretch is decreasing. Down arrows. All right. And it looks like this stretch right here is also decreasing. Okay. So from, looks like -6 to -4, and we have from 3 to 6. Awesome. Wonderful. So a couple things about notation when we use the electronic book to do homework. The book wrongly uses brackets in this situation. So when you see that, they'll likely mark parentheses wrong, is from what we found. So you only need to use brackets in that situation. But please note that it, truthfully, it's got to be parentheses because it's not doing anything at any one particular point. Okay. Now, where is the function going to be constant? Well, what do we have left here? And I'll do this in blue. I think that's what I said earlier. This stretch, whoa, kind of slipped on that one, but that stretch up there is going to be our constant. So it's really doing nothing, just staying flat. Function values are staying the same, they're staying equal. So from 0 to 3, we are constant. All right. Now, just to give you guys a little heads up here, maybe to talk about how to write it in Mymathlab. Mymathlab. So for this particular problem up here, it would have been written like this to get it correct in Mymathlab, which they are wrong. Boo. But we can't change it, so sorry. All right, and then for this one, it would have been -6, -4, and then it looks like separate with a comma is what they usually say instead of the union sign, and you'd have that. And then this last one would have been 0, 3. Again, this is incorrect for intervals of increasing and decreasing, but there's nothing we can do about it in that book, so we have some give and take there. All right? That sounds pretty good. Jenny, you follow along. You make sure to remember that when you're inputting these into Mymathlab. Okay, cool. All right, Jenny's on board, so hopefully you guys are as well. Okay, so down here, the warning. I think we should probably take a look at that since it says warning. Very important. We describe the behavior of a graph in terms of its x values, okay? We do not say the graph is increasing from the point -4, 2 to the point 0, 4, rather increasing on the interval -4, 0, okay? When we're increasing and decreasing, we're talking about our function values, our y values, right? It's up and down. So we're saying, when does that happen? We're talking from left to right, okay? That's what we're talking about there. So when we're talking about our intervals, these are x values that we are talking about, right? Because the increasing and decreasing is talking about the y values, the function values. Cool? So one last little note here. We're not going to get into it now, but when a continuous function changes from increasing to decreasing or decreasing to increasing, it creates maximum and minimum values. So like down here, we'd have ourselves a minimum, okay? And that's something that will be discussed later in our polynomials unit. But for now, we're going to leave it at this. That's it. We're having a great day. I hope you guys enjoy the week. America, freedom, rock and roll, Costco, and River Dog Jenny. If you haven't followed Jenny on the gram, make sure you follow her, River Dog Jenny, Instagram. All right. Peace.